If we're in person, I'd ask who's a database administrator, because I know for well that we are a dying breed. Well, I say we used to be a database administrator. DBAs are a dying breed, and devs these days have lovely tools like Entity Framework to make their lives easier. Today, the agenda is as such. I'm going to go a bit about me, what is this witchcraft, database testing, why we should be testing databases, the different types of testing we can do, a few of the best practices that I've encountered over the years that I feel should be done, and a few misconceptions and ideas about database testing as general to sell it to the business. So myself, my name is Brendon Bezuidenhout-Green. I'm an unashamed Microsoft fanboy. I have used AWS and I've paid for my sins. I've been using SQL now for about 20 years plus. It's not only Microsoft SQL. I've used Oracle, MySQL, do NoSQL, Redis, graph databases. I'm an avid gardener. Love my Lego. You'll see lots of that in my presentation. And I also crochet as a hobby to make blankets and baby clothes for friends. So, what is this witchcraft we call database testing? Well, it's quite easy to put in one simple sentence. It is the software testing that tests the database under test. So the same way that we would normally do our load testing or functional testing with unit tests or load or JMees or whatever it is, it's the same thing can be done for databases. It's just a different way of modeling the information to do our testing. So why should we test databases? Now this is going to be a little bit awkward because I don't have my notes. I want my notes because I've got lots of notes available to me. Did that screen go away?
Yes.
Right. This is going to be really awkward. Share, slide. I love this. This is going really well. So why should we test our databases? Well, for the first thing that we really want to do is we want to make sure that we want people to be doing it, because very few people think about testing databases these days. As I mentioned earlier, software developers these days have lovely tools at their disposal to go and build these amazing databases that systems that use do CRUD, and that's about it. And they bury a lot of the business logic and functional requirements within the software that they use, and they build their unit tests around that and completely ignore the database. There is more value to businesses in the actual data that is stored and the data that is represented and modeled than there is in the physical software. It might cost a few $100,000, £10,000 to build a piece of software, but in 5 years' time, the actual data that is stored within that system will still have value, even though the system itself might have its current use might have expired. And it's not that I hate front-end developers, it's just I don't like JavaScript and CSS. But the front end isn't the center of the universe, which is what a lot of clients and project managers and business as a whole think they need to be testing. They don't need to be worrying about the database because it will just work. It will just scale. For example, reasons to test a database system. If we take a financial system as an example, and the transactions that it processes, now is the information being lost during transmit between the UI or the mobile app and the database? Is there a web API that stopped functioning correctly, or there's been a change to it that we now have to find out where is that information still being retained? Databases like a SQL Server, for example, you can wrap, and Oracle, you can put things in transactions. Now, if there are errors, are those transactions being rolled back effectively? Is there dirty data in your database? Is data being lost? Is there malformed data? Do the users who are accessing your system actually have permission to access your system? A lot of times what you'll find is that developers will use a single security schema to access everything within the database. While I don't agree with this, it's because they haven't really learned to understand or worry about the security, because they think that it's the front end will deal with that and the APIs will deal with that. Your OpenID authentication or whatever authentication method you're using will protect your system and your database, and it's behind a firewall. Well, people like Facebook, for example, have already proven to us that it doesn't matter. Hackers will get through and they will get in. And if you aren't testing the security of your database, then how are you going to be sure that your information is secured, especially given these days of GDPR, which is oh so fun. Right, open publication. I'm going to do this another way because I can get to my notes another way. I can rename the file. No, don't rename. Sorry about this, guys. I really should have tested this, and I'm being very, very naughty by not having tested. So that's that. So, what are the different types of database testing? Well, we have structural testing, and we have functional testing, and we have non-functional testing. Now, a lot of this is very similar to what you might find in a normal testing environment. You want to ensure that your software architecture is built in a certain way. We could do things like that with like UML diagrams, but that's just more of a high-level way of eyeballing, ensuring testing is fine for software. For databases, though, we are looking predominantly for the type of the storage of the data that is not manipulated by users. So anything to do with the data types, are there going to be rounding issues because there's mixed matching of data types in your database? Is your document database expecting specific attributes to be there that aren't being there? Yes, your database can work around that effectively, but if you don't have that information available, it won't be there. Are the field lengths too long? Are they too short? So it's anything to do with the entire structure of the database, because we need to ensure that our heterogeneous databases are consistent with our application, based on either, if you're using the old school waterfall method, your software design documents, or nowadays more with Agile and or Kanban with our user stories and tasks. Are we sure that the actual structure of the database matches what our clients want? And yeah, so this list is not totally, this list is not complete by any length at all. I mean, I could add triggers on here as much as I hate them. But other things about the structure of the server. So you need to ensure that the server itself is validated. Is it the right hardware if you're using store bare metal? All sorts of small things. Microsoft Azure SQL, for example, allows you to query the instance type size through the SQL database, or you can use the information schema to get anything you want. I'm trying to make this presentation as platform agnostic as possible, but I'll be referring back to SQL Server a little bit. So functional testing. So the functional testing of the database is anything that these are the actual functional requirements specified by the user stories. So for instance, a user is not allowed to insert a specific value into a field, or I've got these mixed up, you sausage Brendon. Yes, so for instance, are the field lengths too long? So how many testers, for example, have tried to put in the entire works of Shakespeare into a database? The one that comes to mind is Erlang, recent or a few years back. The text messaging systems that are built these days is built on Erlang, and there were no validation checks in the database system to check that there was no varchar maps. And someone sent the collected works of Shakespeare to someone and rang up a really annoying amount of text messages for them to read. These are things that we don't think about doing on the database because the front end deals with it. This is also the place where you try and make sure that the validation of the fields matches up to the UI. So while I said the UI isn't the center of the universe, it's more that we should be working hand in hand with the UI developers to ensure that there's more cross communication, cross pollination of information. Because a lot of the time they'll be dealing with the more high level discussions and creative design discussions with the clients, and the requirements of what information needs to go where and how it should be stored. There's also data integrity issues to worry about with regards to functional security. So is your referential integrity still intact? If, for instance, you have a users table that you insert a new user and you try and go and attach them to a company, and that company doesn't exist, or the ID doesn't get inserted because the index is incorrectly built, that doesn't allow duplicates based on only the company ID, so that the users table will never allow you to have more than one company in it. And also on the functional side, are there any computed columns in your database? Have these computed columns been calculated correctly? So a good example of this is if you're building a data warehouse, and you build a slow changing dimension, you have something like a data warehouse hash. And these hashes are computed columns based on existing columns in the table to ensure that there is uniqueability whenever a value is updated. And if these aren't, then your dimensions will not be able to effectively update. So you need to ensure the functionality of those computed columns is effectively tested. And no, PowerPoint. Yeah. So it's just refreshing everything I said. There are also the non-functional requirements that we need to worry about. So a lot of these non-functional requirements, are more about risk quantification for the business itself. So the risk quantification in general is like load testing, stress testing, security testing. These quantifications help stakeholders ascertain whether or not the various systems' response times meet their requirements. So stock trading systems have an SLA that have to meet a specific time, and this would be, is the system responding in an adequate and responsive time? These are also the original intent of any QA task. Yeah, we need to know that the load testing itself doesn't mitigate risk, but through the process of risk identification and the risk quantification, presents corrective opportunities that that helps us with remediation and mitigating risk within the system. Does the system meet a minimum system requirements? Now, earlier on, I said about testing the structural of the database, and that's more about the actual server side. But can the system behave on these minimum system requirements? It's very, very much the two sides of the same coin. And the minimum system requirements allow us the understanding to observe through formal testing what the minimum configuration is, and will allow the system to actually behave at the expected performance. With cloud computing, this is less of an issue these days because we can just auto scale if we need to. In some cases, we're using a data lake, and it's just again, it's a scaling problem. Just throw money at it and it will go away. But sometimes these non-functional requirements, like the minimum system requirements, need to be taken into consideration to save costs. I'm sure I've missed something. No, I haven't. Oh, thank God. So the best of the best. These are just a few of the things that I've come across over the years that I think are best practices when it comes to testing databases. So our scheduled jobs are executing in a suitable time. So maintenance tasks are a really good example of this, because if your indexing starts, re-indexing and reordering the page file starts taking longer and longer and longer, there's a possibility that you might have corrupt data in the database that is making things take longer. Does all your data map to the requirements, including your metadata? A lot of the time you'll find that developers will just go and add data to a table willy-nilly without supplying a population script. So when it comes to migrating to QA, UAT, prod, pre-prod, or any other environment, best practice is not to allow the communication between the two, but a lot of people historically have allowed that communication. So when you move to a new environment, if you have a suite of tests, you'd be able to see, okay, this metadata is now missing, and find out exactly why, or spin up a new database server in a Docker container, and then just build the database from scratch. You can just continuously rerun this, and your database effectively becomes immutable software. And your database itself is immutable apart from any other transactions or user submitted data. You could also use something like cause and effect graphing or boundary value analysis to generate required test data conditions. Now, cause and effect graphing is very much a black box testing technique from way back when, that it basically graphically illustrates relationships between given outcomes and the factors that influence them. So, for example, if a user selects an option from a dropdown, and you're expecting the dropdown to be a string value, what happens if you type something into the dropdown? Does that value then go through to the database? So this is a way of trying to map the influences on the factors on those influences. So the user's doing something you don't expect. And then boundary value analysis is a software testing technique that you can actually use for databases, in which the tests are designed to include representations of boundary values in a range. And the idea comes from a boundary, as it were. And given that we have a set of test vectors to test the system, and the topology can be defined from that set. Validate your output data. A lot of people will use things like JMeter to do their interface testing. There's nothing wrong with using a mixture of, say, JMeter to go and update the front end and get it to execute a store procedure to ensure that or a select statement that ensures that the data is there, or you can physically go and look in the database and ensure that there is the data you expect. And if not, then, well, software dev made a boo-boo, or the DBA made a boo-boo. Backup regularly. I cannot stress this enough. A lot of times, if you, I have in the past, in my youthful ignorance, truncated production tables because I didn't wrap things in transactions. And if I'd backed up more regularly, I would not have had that. Lesson of the day: I wrap everything in transactions now, and I always roll back. But if you don't have that mental training and safety net, keep on doing it. And the last one is more common sense. If you think that something can be tested in a database, there's no reason it shouldn't be tested. There are a lot of tools out there that can allow you to create unit tests for databases. Like DB Unit was one way back when. SQL Toolbelt has got a few options in it. So Redgate Redgate have got a very good suite these days, and there are a few more periphery ones that I've not used as yet, but they have got some really good reviews about them. Last, a few of the myths about database, wrong slide here. A few of the myths about database testing. So database testing is tedious, and I will be the first to tell you, yes, it is very tedious, but I find writing unit tests very tedious. So we still write unit tests as software developers and software engineers. So why don't we test our databases? Why don't we show them some of the love and pride that we take in our software? We use those unit tests to prove ourselves right and to know when things go wrong. The amount of times in the past I've seen systems where they've not updated the database, and they've updated a database, removed a column, and the software falls over completely. Little Bobby drop tables, I'm sure everyone knows from XKCD, is another good example of testing your databases. Effective testing in any system is hard work, but it provides long-term functional stability to the overall system. And all of those late night call outs to the support team, they will thank you at the end of the day. Database testing creates bottlenecks is one of my favorites, because so does unit testing. Unit testing creates as much a bottleneck as software testing. Numerous times in the past, and even now, I've seen companies where they expect the developers to have unit test coverage of 75, 80%. In one instance, I saw they had to have a 90% code coverage. Now, how many of those tests are actually valuable and have value to the business is a very good question, because they could just be gaming the system and testing all their models, or just writing unit tests for the sake of unit tests. But that's creating a bottleneck as much as database testing is, but it still provides functional stability moving forward. Database testing is expensive. So yes, it is, but so is unit testing again. The reality of this is that, and the expenditure on testing the database, as much as you spend on writing the unit tests, it's a long-term investment for the stability and robustness of the application. And expenditure on the database testing is necessary if you want to ensure that things are stable in the end. If you want to, in 5-10 years time, or you have an investor that comes in and wants to buy the system that you've built, they aren't interested in the system more often than not. They are interested in the data. And if your data is full of inconsistencies and null values and holes, then your data is effectively worthless. What else? Database testing requires plenty of expertise, is another one that I haven't added to that list. So unit testing in any software development in any language requires expertise. You can get a junior developer to go and write a unit test, and if that unit test has value, awesome. But more often than not, the first few times it is a learning experience, and it takes time. The same is with any other type of software testing or systems testing. Whenever you start it is going to take you time to gain that experience and understanding of how to do it. And it is going to take a bit of time, but the hard work that gets put in behind that really pays dividends moving forward, because eventually you might get to a point where you think, okay, I know I don't need to test this because I've got additional structural tests for higher up that could make things work better. That's it, really. Yay. Oh, it is out. No, it isn't. Oh, it is out. That's it. I did have a slide for questions and answers, but I used that for Ryan. Are your headphones working? So I deleted it, I'm afraid.
And the answer is yes.
You can hear me now.
I can hear you, yeah.
Cool.
Well, I guess on that point, is there any questions? I don't think there's a hands up button on here, but if you do have questions, then feel free to unmute and shout.
As I said, I try to make this more high level than actually get into the nitty gritties when I put it together, because I was concerned that it was going to become too platform specific, like writing unit tests and proving unit tests for SQL Server stored procedures, or certain vertices and edges in a gremlin database, which a few people would understand, or any of the hashes in a Redis database. So yeah, I do apologize about that unashamedly.
So one of the things that I've come across before is people saying, well, actually, if I test the UI and my test works, that proves the database works. Is there anything that you know, what would you respond to, you know, comments like that?
I would get the collected works of Shakespeare and paste it into that field. And make the system crash.
You can answer that as well, Ryan.
Yeah, please do.
So we've had issues recently. I won't go into our products, but we've had stuff where it functionally seemed to work, and then over the course of 2 days, it then suddenly stopped working. We have a lot of syncing going on with databases and hypersync and all that sort of stuff, and we've lots of stuff there around either over time we get issues, or I suppose you can also get memory, etc., or logs are another one. But we've also had stuff where incorrect use of variables, so int instead of integer, and that's suddenly broken stuff. And what it's shown is that can be across so many different things that if we haven't got the breadth of testing to that, or we haven't done the right level to begin with, then you can find it was only because we were doing a demo to someone we spotted it and stopped it live. Otherwise, we would have broken live.
My point is proven. No, I totally hear what you're saying.
I'm not suggesting that is my opinion, by the way. It's just devil's advocate, just throwing it out there.
Yeah. Yeah. I'm trying to think how to get around that. Yeah, it's a lot of the time it's just execute the stored procedure, make sure it works. Or yeah, it comes down to the data types. So coming back to Ryan's point about I've made the change on the front end, which is an argument a lot of people say. And then you go and look at the database, and there could be a rounding issue, but the front end developer has actually accounted for that. Percents are a really good one, because it's so easy to do it now in JavaScript or CSS to represent a value as a percent. And if they expect it to come out of the database in a specific format, and they represent it, but your database is showing a completely different value as what you would expect it to be. Is there a rounding issue? You don't know unless you look at the data. And it is, as you said, Peter, loss of data because things haven't been tested correctly is terrifying. Keeps me awake at night.
Cool. Just want to say thanks to Brendon for his talk. And hopefully I'll see some of you again on future meetups.